Okay, so let's start out with a straightforward example. This would be example 1. We're going to find the area between the curves y equals sine of x plus 1 and y equals cosine of x minus 1 on the interval from 0 to 2 pi. So you don't have to sketch a picture of this to solve this problem, but let's do it anyway. Just it gives us an idea of what mistakes we might make and sort of how this is working. And we're going to need to go down here because I've moved both of these functions around. So let's think about what's happening. I'm taking sine of x, which usually bounces between 1 and -1 here, and I've scooted it up 1. And so every time it would have been at 0, now it'll be at 1. Every time it would have been at -1, it'll be at 0 and 2, right? And we're going between 0 and 2 pi. So let's just think about what sine does on this interval. It starts usually at 0, but now at 1, goes up, and then goes down, comes back. And, it keeps going, but this is y equals sine of x plus 1. And then what happens to cosine? Well, normally it starts at 1 and goes down and around, but now we're going to start at 0 because we've scooted it down 1, and we're actually going down to -2. So we're starting at 0, it goes around, and by the time we're at the middle, we should be at the bottom of the wave, and then we'll come back up to 0 when we get to 2 pi because it's been scooted down, and of course it keeps going. Blah, blah. All right, so this is y equals, or approximation of y equals cosine minus 1. And so what's the area we're looking for? Well, we've been given our a and b. We don't have to solve for it or anything. So we're going to, chop the area off on this side here and this side here. And so what is this area in between? Okay. And so all the elements we have are here. We're going to set up an integral. It's going to go between our x values that we're concerned about, which is 0 to 2 pi. We're going to take our sort of ceiling function, which in this case is y equals sine of x. Oh yeah, I don't need the y, so let me get rid of that. So it's sine of x plus 1, so that's our ceiling, and then our floor is cosine x minus 1. And so this is the function I need to take the integral of, the difference of these two things. So let's simplify it a little bit, and then we'll just find the definite integral. Okay, so we have sine of x. This is going to give me a minus cosine of x. And then I have a plus 1 minus a -1, so that's really a plus 1 too, so I'll end up with plus 2. Okay, so now we can take the integral. So the antiderivative of sine of x is negative cosine, since the derivative of cosine is negative sine, and the antiderivative of negative cosine is still negative sine because the derivative of sine is cosine. And then 2, remember any antiderivative of a constant is just the variable we're using times that constant. Okay, so now we have our function. We're going to plug these values in. So I'm going to scoot over here because it's going to take a bit. So I need to plug 2 pi into all this and then plug 0 into all this and see what I end up with. Okay, so minus cosine 2 pi minus sine 2 pi plus 2 times 2 pi. So there's plugging 2 pi. Now we'll plug in 0. So minus cosine 0 minus sine of 0 plus 2 times 0. All right, so let's remember what these values are. So cosine of 2 pi, it's, we're thinking about the unit circle. 2 pi is over here, and the cosine value is the x value of this point, which in this case will be 1. Right? So this is minus 1. The sine of this value is 0 because we're on the x-axis in that picture. So minus 0, and this is 4 pi. And then we're going to subtract off cosine of 0. 0 and 2 pi are at the same place, so these cosines and sines will be exactly the same. So minus 1 minus 0, and then 2 times 0 is 0. And so what happens is we have minus 1 plus 4 pi. The zeros are gone, and then we have a plus 1 here, and those zeros are gone. And so really, in the end, all we have is 4 pi. And so what we found is that the area between these two curves on the interval from 0 to 2 pi is 4 pi.